What if the most powerful learning tool we've ever built also quietly makes us worse at learning? AI in education is a paradox. It can amplify thinking, or it can erode it. Today, I'll break down both sides, what's actually happening in our brains, and a practical framework for using AI as a mindful partner instead of a cognitive replacement. AI is entering classrooms, study routines, and even how we write, solve problems, and prepare for exams. Here's the tension. On one hand, AI can boost learning through personalization, feedback, and deeper inquiry. On the other hand, it can increase cognitive offloading, handing thinking to the tool, until independence and deep understanding start to fade. This is about maximizing enhancement while preventing erosion. A common argument is AI is just like a calculator, but for language. That analogy sounds comforting, but it's misleading. Calculators produce bounded output, one correct answer, reliably. Generative AI doesn't work that way. It infers and guesses, and it can hallucinate, fabricating legal cases, inventing citations, or generating confident nonsense. There's also an ethical footprint calculators don't have. Complex labor issues, massive energy and water consumption for data centers, and resource extraction like copper and lithium mining. And unlike calculators, generative AI can affect autonomy. Overuse can erode independent reasoning and increase cognitive offloading, almost like autocomplete for life, where decisions get handed to opaque systems. Finally, AI can reproduce power relations. It's trained on human language shaped by unequal histories, so it may inherit and reinforce dominant linguistic forms while sidelining less privileged ones. So no, this isn't just a calculator. Let's get concrete. What's the promise and what's the peril? The promise is cognitive enhancement. AI can personalize learning, adapting examples and difficulty to your level, making practice more effective. It can push deeper analysis by generating counter-arguments and challenging questions. And it can strengthen procedural skills with real-time, adaptive feedback while you work through complex tasks. But there's a real risk of cognitive erosion. Over-reliance can create intellectual dependency, especially for brainstorming and recall, reducing independent reasoning and long-term retention. AI can also encourage superficial engagement, quick answers that skip the struggle needed for deep learning. In one comparison, AI-assisted students solved significantly more math problems correctly, yet scored lower on conceptual understanding. That's the trade-off. Are we training competence or just accelerating completion? AI doesn't have to be an answer machine. If implemented strategically, it can become a thinking partner. One method is scaffolded questioning and debate, where AI proposes conflicting viewpoints, so learners must evaluate evidence and synthesize arguments. Another is real-time adaptive feedback. Instead of giving the solution, AI gives hints that force justification and revision. Then there are personalized learning paths that tailor problems to student interests to increase engagement without lowering rigor. And finally, structured metacognitive development. Learners verify outputs, check sources, and reflect on their reasoning. The theme is simple. AI should increase thinking, not replace it. So what drives the erosion? First, cognitive offloading, delegating cognitive tasks to external tools. Second, erosion of independent reasoning, because quick answers are always available. Third, superficial engagement and bypassing struggle, which can promote passive learning. And fourth, algorithmic bias and filter bubbles. AI tools can reflect prior interactions, reinforcing existing beliefs and narrowing exposure to diverse perspectives, exactly what robust thinking needs. Now let's connect this to learning science. Cognitive load theory says working memory is limited, and learning depends on managing three types of load. Intrinsic load, which is the difficulty of the material. Extraneous load, which is wasted effort from distractions or non-essential tasks. And germane load, which is deep processing that builds understanding. AI can reduce extraneous load, which is great. But over-reliance can also reduce germane load because the learner offloads the very thinking needed to form lasting mental models. There's also a brain angle. Learning complex tasks relies on a partnership between the prefrontal cortex, which handles goal-directed rules and procedures, and the hippocampus, which helps form rich, context-specific memories. AI is excellent at automating procedural rules, but if it prevents deep engagement, it may weaken the kind of processing that supports durable learning. Here are 4 common pitfalls, and what to do instead. Pitfall 1. Unsupervised AI use and academic shortcuts. Copy-pasting a solution skips reasoning. Fix. Teach AI literacy and use prompts that guide learning, like step-by-step coaching instead of final answers. Pitfall 2. Task oversimplification and surface-level analysis. A bullet summary can miss nuance. Fix. Scaffolded debriefs where students expand AI summaries into deeper analysis or identify what the summary missed. Pitfall 3. Cognitive offloading and intellectual dependency. Repeatedly asking AI to list steps can weaken recall. Fix. Hybrid workflows. Start with no AI notes, then use AI to refine, and require reflection comparing human versus AI contributions. Pitfall 4. AI avoidance due to fear or distrust. Some students avoid AI entirely and miss a chance to build evaluation skills. Fix. Safe, low-stakes practice where learners identify and verify flawed outputs using trusted references. A mindful strategy needs two pillars: understanding cognitive mechanisms and anchoring everything in ethics. Key cognitive principles include managing cognitive load, fostering metacognition, promoting active recall, and balancing procedural and conceptual learning. Key ethical principles include human agency and oversight, fairness and non-discrimination, transparency and accountability, and privacy and well-being. To make this real, ethics can't be a patch after deployment. It has to be built into the process. A practical life cycle looks like this: specify objectives, specify requirements, create a high-level design, collect and prepare data, build in detail, then test and evaluate. Early on, ask, could this system limit rights, deceive, or manipulate? What's the risk of misuse? What harms could occur? Then translate ethical goals into real requirements, risk and impact assessments, ethics by design plans, and governance with meaningful stakeholder input. In design and data, assume data may be biased until proven otherwise. Do bias assessments, document corrections, ensure strong data governance, and build oversight like logging and audits from day one. Finally, test ethical compliance like you test functional bugs. Check bias, safeguard integrity, document decisions, train staff, verify user understanding, and keep feedback channels open. The goal isn't to ban AI or blindly embrace it. It's mindful partnership. AI should complement, not replace, human reasoning. We must manage the trade-off between procedural efficiency and deep conceptual learning. And if we embed ethical principles into how we design and deploy these systems, we can foster intellectual autonomy rather than dependency. Thanks for watching. If this was useful, consider subscribing and tell me in the comments, how are you using AI in your learning without letting it do the thinking for you?